Hi everyone, I'm Huiying Valerie and I'll be presenting on using blockchain for private real estate Know Your Customer or KYC and customer due diligence, also known as CDD checks. I'll first give a brief overview of how KYC, CDD and AML regulations play a role in real estate. There are many third parties involved in these processes, serving many purposes, but one of the most important reasons is to conduct due diligence and KYC checks in order to comply with anti-money laundering regulations. This is due to the inherent appreciative and functional nature of property, which makes the industry more attractive as an avenue for money laundering, as criminals can invest in property to legitimize their illegal proceeds. I will not go too much into detail about what KYC and CDD is, but the information will be on these two slides. Both the buyer and seller have to go through CDD, and I have separated them as so. The issues of current traditional KYC and CDD checks are as follows. When applying for different services related to real estate transactions, clients need to repeatedly submit the same documents to different institutions. This results in a poor customer experience and inconsistency of documents. Secondly, there is a significant financial cost for organizations as these checks are carried out in parallel. There is also inadequate security and availability of documents as they are stored on centralized database systems that often have a single point of failure. Another issue is the bundling problem, where clients do not have selective disclosure over what personal data is exposed to different organizations, and this project aims to tackle these issues. Further motivations of this project is the growing popularity of Web3 and the Metaverse, which are emerging technologies potentially transforming the next version of the internet and digital platforms. This video shows an example of an estate in the Metaverse made by another student, Dylan. So by having a KYC platform built on blockchain, this will hopefully achieve more interoperability with the Metaverse. I thus propose a solution that aims to serve as a proof of concept to address this. First, I define the scope, which is aimed at private residential property and retail clients in Singapore. The overall objective of my solution is to streamline the KYC and CDD checking process of the real estate sector and to provide a one-stop platform for clients to upload their documents in a safe and secure manner. I followed an agile methodology to better manage my project. As shown on this Kanban board, I divided the project into sprints of different durations depending on the workload. This is the system architecture. The KYC CDD UI is the user interface, which is used mostly by clients who want to upload their documents and control permissions as to which entities in the network can view their documents. IPFS is used for document storage as it is decentralized and helps to avoid a single point of failure. The KYC CDD service acts as a central point to the other components, containing all necessary software, drivers, and APIs to interact with the blockchain and IPFS. As for the blockchain, Quorum is used, which is a permission blockchain network developed by JP Morgan and currently maintained by Consensus. It eliminates the need for gas fees and plays well with popular Ethereum tools. It also provides the ability to make contracts and transactions private, which is important as we are dealing with sensitive user documents. There are three use case scenarios that is present in the proposed system. First is the verification of documents. Once a user uploads documents to IPFS, a valid verifier that is registered with the blockchain network can proceed to verify them. A unique hash will be generated that will be placed under the verifier's contract as proof that the document is verified. Next, users can also grant or revoke permissions for existing entities in the network. A user who is buying a property and selling another would have BCDD and SCDD documents uploaded. He or she can then give BCDD permissions to entities who are involved in the buying process and SCDD permissions to those who are involved in the selling process. This ensures a certain level of privacy for the user, as entities are not able to view all documents, but only those necessary for the business or service that they are providing. These permissions are stored in the user contract. Lastly, a participating entity can retrieve documents, and the process is shown in this flowchart. The system checks if the entity has permission from the user to view that particular CID and will be able to retrieve it if they have permission to do so. They can then proceed to get the documents from IPFS for the necessary checks. Now, I'll be giving a video demonstration to better illustrate these processes. I have started the blockchain network, which is built as a Docker container. Quorum also provides an Explorer page, where you can see the nodes over here and also inspect transactions that will happen over here. For deploying the smart contracts to the blockchain network and to interact with these smart contracts, I'll be using Truffle. There are 3 members in the blockchain network: member 1, member 2, and member 3. I'll be using member 1 as a regulator to deploy these contracts. So over here, you can see that the user factory contract and the admin contract has been deployed. As you can see here on the Explorer page, the contracts have been successfully deployed. This is the UI I have created for the demo. So this is the user homepage, and the user that I am using has the address of 0x627 and ends with EF57. And I'm using MetaMask to interface with the blockchain. I'll first simulate a user to upload files. I'll first upload a KYC driving license file, as shown here, and click Submit. Once the file is uploaded to IPFS, a CID is returned, and the user has to submit a transaction to store this in the blockchain. When this is successful, we can see the success message as well as the CID here. Here, I'm doing the same for a BCDD document, which is the user's proof of funds. Here, we can see that the CID is different from the previous one. Now, I'll simulate the user granting permissions. This is the page where the user can view a list of participating entities and who to give permissions to. For now, we will give law company KYC permissions, but not BCDD permissions. So after granting permissions, we can see that the KYC permission is granted. So now I'm on the entity homepage, and I am logged in as the law company entity. We will try to get both the user's KYC and BCDD CID, but we should only be able to get the KYC CID as only permissions for that are granted by the user. Let's try the BCDD one first. So this is the user's address, and I'll type BCDD inside. As shown, the company does not have permissions to view this CID. Now let's try the CID of the KYC documents. As shown, we can see that we can get the CID, but we also see that this CID has not been verified. This is the verifier's homepage. A verifier can be any trusted notary that is fit to validate the documents. So for the KYC driving license document, this can be the transport authority. First, we need to search the user's CID. After getting the CID and viewing the documents from IPFS, the verifier can proceed to press this button to verify the documents. Once the transaction has been submitted to the blockchain, this success message will appear. We are back as the law company on the entity homepage, and now if we check to see the KYC CID, we can see here that it has been verified. For the demo of private transactions, I'll be using the command line to demo this. In our blockchain network, member 1 and member 3 are approved entities, while member 2 is not. This means that member 2 cannot view the data in the admin contract, which is a private contract. As seen here, when member 3 tries to get the user's CID from the admin contract, the CID will be returned, as member 3 is an approved entity of the blockchain network. When member 2 tries to query the KYC CID from the system, there will be an error thrown, as member 2 is not an approved entity of the blockchain network. This shows that the private admin contract works, as it is not accessible to members outside of the blockchain network. So to conclude my presentation, these are the following benefits of my solution that targets the earlier mentioned issues. Thank you.